Okay, so let's do control chart for attribute together using Excel. And I enter the data for your sake, and I'm gonna make this spreadsheet available for you. And we have the errors. Notice that out of 100 products, there were 6 defectives. Out of 100, 4, and sample 19, 0. And that is the case. So therefore, fraction defective equals 6 over 100. So before doing that, let us write down the sample size. So which is 100. The sample number is 20 because we have 20 times sampled. And the total sample size equals 100 times 20. And total defects equals sum of all these errors, and that's 80. Percentage defects equals, so 80 over 2000, and standard deviation of p bar equals, we have to use a function. So p bar equals actually, what is the formula? So let me show you. P bar is total number of errors divided by total number of records examined. So 80 over 100 times 20 gives you that. And we have to calculate sigma hat p equals square root of p bar times 1 minus p bar over 100. So that's what we need to do. So equals square root sqrt, and you got to use the parentheses as well. So nominator is p bar times 1 minus p bar, right? And then you can, the nominator was done. So now denominator equals divided by 100 because that's the sample size. So to simulate everything, I'm going to just click on that and close the parentheses. Then we have 0.02 as we calculated here. We have standard deviation of p bar here. And z value that we are going to use is 3. So I'm going to just type 3. So upper control limit. So the upper control limit is p bar plus equals p bar is right here plus z value times sigma standard deviation of p bar. So that's there. And center line is the p bar, and lower control limit is p bar minus z times standard deviation. And we have negative, and we don't want to get negative. So what we do is maximum 0 and that, compare 0 and this value and pick a value that is greater, right, among them. So if it's 0 is greater than negative value, it will pick it up. If it's positive, that value will come up. So we have 0 there. So we find these values. So then, we can calculate this fraction defective 6 divided by 100, and I want to use absolute reference. So I'm adding dollar sign there. Let's J and dollar sign over there. So I'm using this absolute reference, and then scrolling down, and I copy the formula. So the percentage is there, so you can add percentage and increase one decimal place. So you have that. Upper control limit is right here, 0.10. So I'm going to give that there, and I'm going to just fix that because that's a upper control limit no matter what in this data. So I have that. Center line the same, 0.04, and J36, their lower control limit is 0, right? So To simulate, I'm using this, rather than typing, I'm just putting all this absolute reference for your sake. And then you can draw that, and I have this one. If you want to do it yourself, what you can do is you can just select this percentage here, right? Four of them, and you can go to Insert and Data, just a scatter plot, or you could use a line graph like this, and you have it, right? So you have a line graph there, and you can change the name to P chart, P chart, and that's it, right? However, I can make it look nicer, and right here, P chart is constructed for you. You can try different layout and different colors, and we see that sample 17 is obviously problematic because it went out of the boundary. So we may need to look at that. And I don't see particular problem here other than this one. So, so that's how you can draw the P chart. Lastly, let's also work on CP. CP is process capability. It should be at least 1 or 1.3. 2.0 is even better. So let's see, CP is upper specification. So upper specification minus lower specification divided by parentheses. You have to use parentheses for denominator. So 6 times sigma is given as 0.02, and we have 0.84. So this is not capable process. So we can tell that it's below 1. What about CPK? We need to see whether it's centered or not. And CPK equals minimum. So we start with a minimum, and the parentheses upper specification minus center line divided by 3 times sigma. So you have to use parentheses again for 3 sigma. 3 times sigma is 0.2 and comma. So you have to compare this value to the other set of values, and that is x bar minus lower specification, which is 0, divided by 3 times sigma. Sigma is 0.02, right? So you compare them together, bring up minimum of that, and that's 0.68. So therefore we see that it's tilted to the right. That's what we see, and it's not centered. That's what we see with the CPK as well. It's not capable process. It's tilted to the right. That's what we can interpret from CP and CPK information. I hope this exercise was helpful for you. Thank you.